Have you ever stopped and wondered how your phone just knows it's your face, even when you're wearing a hat? Or how your music app serves up a new song that you instantly love? It really does feel kind of like magic, doesn't it? Well, today we're going to pull back that curtain, because what seems like magic is actually a really fascinating process that's running behind the scenes of our daily lives.
I mean, think about it for a second. When a junk email gets zapped into your spam folder, there's not some little guy inside your computer reading everything and making a call. And when a shopping site shows you the exact pair of sneakers you were just thinking about, well, that's not just a lucky guess.
Nope. What's really going on is a powerful system is at work, a system that doesn't just blindly follow instructions, but one that actually learns from experience. And this whole idea is the foundation of a pretty revolutionary field in computer science. And that field is called machine learning, or ML for short. The best way to think about it is like this. In the old days, a programmer would have to write specific rules for everything, like a huge list of spammy words. With machine learning, we do something way smarter. We just show the computer thousands of examples of spam and thousands of examples of good emails, and we say, you figure it out. It learns the patterns on its own and then makes predictions on new emails it's never seen before.
So, how does a machine actually learn? What's going on under the hood? Well, you can think about it like you're baking a cake. To get a perfect result, you're going to need a solid recipe with the right ingredients. First up, you need your ingredients. That's your data. It's all the experience the machine is going to learn from. Second, you need a model. This is basically the recipe itself, the set of rules the machine uses to figure out the patterns in the data. And third, and this is crucial, you need a loss function. This is the taste test. It's a way to measure how wrong the model's predictions are. Let's say the model predicts a house will cost $500,000, but it actually sells for $510,000. That $10,000 difference? That's the loss. And the whole game is to keep tweaking the recipe to get that loss as close to zero as you possibly can.
But here's the thing. You can't just throw all your data in the bowl at once. You have to be smart about it. We split it into 3 piles. Most of it is training data. This is what the model studies to do its initial learning. Then you've got validation data. Think of this like pop quizzes to help tune the recipe and make sure it's on the right track. And finally, you have the test data. This is kept totally secret until the very end. It's the final exam, where the model has to prove it can handle brand new information it has never ever seen before.
Okay, so just like there's more than one way to bake a cake, there are different ways for a machine to learn. Let's dig into the 4 main flavors of machine learning.
We're going to cover the big 4 here. We'll start with the 2 most common, supervised and unsupervised learning. Then we'll get into a really cool one that learns from rewards and punishments. And finally, we'll talk about the powerhouse that's behind all the crazy AI stuff you hear about these days, deep learning. So let's start with the 2 big ones. Supervised learning is kind of like studying for a test with flashcards. The data is all labeled. You show the computer a picture of a cat and you tell it, this is a cat. It gets the picture and the answer. Unsupervised learning is the complete opposite. It's like I dump a giant box of animal photos on your desk and just say, sort these. You have no labels, so you have to find the patterns yourself. You might start making piles, these have pointy ears or these have spots, without even knowing what a cat or dog is. So supervised learning is really all about prediction. You use it when you're trying to find a specific answer. This breaks down into 2 main jobs. There's classification, which is about sorting things into buckets, like is this email spam or not spam? And then there's regression, which is all about predicting a specific number, like what is the exact price of this house going to be? Unsupervised learning, on the other hand, isn't for prediction. It's for discovery. A common task is clustering, where a business might group its customers into different segments based on their buying habits, revealing groups they never even knew existed. And then there's association. This is the engine behind those customers who bought this also bought features. The machine discovers on its own that, hey, people who buy peanut butter also tend to buy jelly.
All right, let's switch gears to something different. Reinforcement learning. Honestly, this is a lot like training a dog. You have an agent, which could be a robot arm or an AI in a video game. It tries an action. If that action helps it reach its goal, you give it a reward, like a digital treat. If it's a bad move, no treat. After millions and millions of tries, it learns the absolute best strategy to get the most rewards. This is exactly how computers mastered incredibly complex games like chess and Go.
And finally, we have deep learning. You can basically think of this as machine learning on steroids. It uses these really complex structures called neural networks that are loosely inspired by our own brains. They have lots and lots of layers. So if it's trying to recognize a face, the first layer might just spot simple lines and edges. The next layer combines those into shapes, like an eye or a nose. The next layer puts those together, and boom, it recognizes a face. This layered approach is what lets it handle the really complicated stuff, like understanding your voice commands or even driving a car.
Okay, so we've got the concepts down, but how does an idea like "let's detect fraud" actually turn into a real feature in your banking app? Well, that happens through a pretty clear, step-by-step process.
It all starts with data prep. And seriously, this is one of the most important steps because, as they say, garbage in, garbage out. Once the data is clean, you do the model training. This is where the actual learning happens. After that, it's exam time. You evaluate how well it does on that test data. If it passes, it gets deployed. You release it into the wild. But the job isn't done. You have to constantly monitor its performance to make sure it keeps working correctly as new data flows in.
So let's zoom out and put all this together. Because this isn't just theory for a textbook. Machine learning is here, right now, and it is fundamentally changing our world.
The applications are, well, they're everywhere, in pretty much every industry you can think of. Those product recommendations that seem to read your mind? ML. That instant fraud alert on your credit card? ML. In healthcare, it's helping doctors analyze X-rays to spot diseases earlier and more accurately. It's the brain behind self-driving cars. It's how search engines figure out what to show you. It's truly the silent engine powering so much of modern life.
So it's pretty clear that machine learning is not science fiction anymore. It's a real tool that we're using to learn from data and make incredibly complex decisions. Which leaves us with a really big, fascinating question to think about. As these systems get more and more capable, what are the most important values and goals we, as humans, should be teaching them?